Have you ever wondered why things fall down and not up? It's a question that has puzzled humans for centuries. The answer lies in the force we know as gravity. Gravity is the invisible force that pulls objects towards each other, and it's what keeps us grounded on Earth. Without gravity, we'd all be floating aimlessly into space. Or how your phone can send messages through thin air. This seemingly magical process is actually a triumph of modern physics. When you send a message, your phone converts your words into electrical signals. These signals are then transmitted as electromagnetic waves, which travel through the air to reach the recipient's phone. It's a complex dance of energy and information, all governed by the principles of physics. Physics is the study of how the universe works. It helps us understand the fundamental principles that govern everything from the tiniest particles to the vastness of space. Scientists in labs around the world conduct experiments to uncover these principles, using advanced technology and creative thinking to push the boundaries of our knowledge. It's about understanding the fundamental laws of nature that govern everything around us. These laws are like the rules of a game, dictating how objects move, interact, and change. By studying these laws, we can predict how things will behave in different situations, from the motion of planets to the behavior of subatomic particles. From the smallest atoms to the largest galaxies, physics is the key to unlocking the secrets of the cosmos. At the atomic level, physics explains the interactions between particles that make up matter. On a grander scale, it helps us understand the formation and evolution of galaxies, stars, and planets. The more we learn, the more we realize how interconnected everything is. But physics isn't just about complicated equations and abstract theories. It's also a practical science that has real-world applications. In classrooms and labs, students and researchers solve problems that can lead to new technologies and innovations. Whether it's developing renewable energy sources or improving medical imaging, physics plays a crucial role in advancing our society. It's all around us, in the everyday things we do and see. From the way a ball arcs through the air when you throw it, to the way your car accelerates when you press the gas pedal, physics is at work. Understanding these principles can give us a deeper appreciation for the world and help us make better decisions in our daily lives. So, get ready for a wild ride as we explore the fascinating world of physics and discover the science behind the ordinary. We'll dive into exciting experiments, unravel the mysteries of the universe, and see how physics shapes our everyday experiences. Whether you're a seasoned science enthusiast or just curious about how things work, there's something here for everyone. Let's embark on this journey together and uncover the wonders of physics. Let's start with a force we all know and love: gravity. This fundamental force is something we experience every single day yet often take for granted. From the moment we wake up and place our feet on the floor to the time we jump, run, or even just stand still, gravity is at work. This invisible force is what keeps our feet firmly planted on the ground. Without gravity, we would float aimlessly into the sky, unable to stay grounded. Imagine trying to walk or run without this force. It would be impossible. It's also what keeps the Earth in orbit around the Sun. The gravitational pull between the Earth and the Sun ensures that our planet follows a consistent path, providing us with the stable environment necessary for life to thrive. This delicate balance is crucial for the changing seasons and the passage of time. Gravity is a force of attraction between any two objects with mass. This means that every object in the universe, no matter how small, exerts a gravitational pull on every other object. The strength of this pull depends on the masses of the objects and the distance between them. The more massive an object is, the stronger its gravitational pull. For example, the Sun, being much more massive than the Earth, exerts a stronger gravitational force, which is why the Earth orbits the Sun, and not the other way around. That's why we feel Earth's gravity so much more than the pull of a book. The Earth is incredibly massive compared to everyday objects, making its gravitational force much more noticeable. This is why we don't feel the gravitational pull of smaller objects around us. Think about throwing a ball up in the air. When you throw it, you're giving it an initial force that propels it upwards, away from the Earth. The ball goes up, slows down, stops for a brief moment, and then comes back down. This entire process is a beautiful demonstration of gravity at work. The ball's upward motion is counteracted by the gravitational pull of the Earth, causing it to decelerate, pause, and then accelerate back downwards. This is gravity pulling the ball back towards the Earth. It's a constant reminder of the invisible force that governs so much of our daily lives. Whether we're playing sports, driving a car, or simply walking, gravity is always there, ensuring we stay connected to our planet. Remember playing with magnets as a kid? That's electromagnetism in action. It's the force that causes magnets to attract or repel each other. But electromagnetism is much more than just magnets. It's also responsible for electricity, which powers our homes and devices. From the lights we read by to the computers we use every day, electromagnetism is essential to our modern lives. Here's a fun fact. Did you know that Earth acts like a giant magnet? Its magnetic field protects us from harmful radiation from the sun. Pretty cool, right? Ever wonder how a pot of water boils? Or how your refrigerator keeps your food cold? That's thermodynamics at work. Thermodynamics is the study of heat and its relationship to other forms of energy. It explains how heat can be transferred from one object to another, and how it can be used to do work. One of the most important laws of thermodynamics is that heat always flows from hotter objects to colder objects. This is why a hot cup of coffee cools down over time, and why ice melts in a warm room. We see the world around us because of light. Light is an essential part of our daily lives, allowing us to perceive the beauty and complexity of our surroundings. From the vibrant colors of a sunset to the intricate details of a flower, light reveals the world in all its splendor. But have you ever stopped to think about how light actually works? It's something we often take for granted, yet it's fundamental to our understanding of the universe. Light is not just a simple phenomenon, it has fascinating properties and behaviors that scientists have studied for centuries. Light is a form of electromagnetic radiation that travels in waves. These waves are part of a larger spectrum that includes radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Each type of electromagnetic wave has a different wavelength and frequency, but they all travel at the same speed in a vacuum, the speed of light. These waves can be reflected, refracted, and diffracted. Reflection occurs when light bounces off a surface, changing direction, but staying in the same medium. Refraction happens when light passes from one medium to another, bending as it changes speed. Diffraction involves the spreading out of light waves as they encounter obstacles or pass through small openings. Reflection is what happens when light bounces off a surface, like a mirror. This is why we can see our reflection in a mirror, or why a shiny surface can reflect light. The angle at which the light hits the surface determines the angle at which it is reflected, following the law of reflection. Refraction is the bending of light as it passes from one medium to another, like from air to water. This bending occurs because light travels at different speeds in different media. For example, light slows down when it enters water from air, causing it to bend. This principle is used in lenses to focus light and create images. This is why a straw in a glass of water appears to be broken at the surface. The light bending as it moves from the water to the air creates an optical illusion, making the straw look disjointed. This effect is a common demonstration of refraction and can be observed in many everyday situations. Diffraction is the spreading out of light waves as they pass through an opening or around an obstacle. This phenomenon can be seen when light passes through a narrow slit or around the edges of an object, creating patterns of light and dark bands. Diffraction is a key concept in understanding wave behavior and has important applications in various fields, including optics and acoustics. Section 6. Sound vibrations that we can hear. Sound is all about vibrations. When something vibrates, it creates waves of pressure that travel through a medium like air or water. These waves reach our ears, causing our eardrums to vibrate, and our brains interpret these vibrations as sound. The pitch of a sound is determined by the frequency of the vibrations. Higher frequency means a higher pitch, and lower frequency means a lower pitch. The loudness of a sound is determined by the amplitude of the waves. Larger amplitude means a louder sound. Section 7. Pressure, the science of squeezing. Pressure is all around us. It's the force exerted on a surface per unit area. We experience pressure from the air we breathe and the water we swim in. Here's a fun experiment. Try pushing a thumbtack into a piece of wood. You'll notice it's much easier to push the tack in with the pointy end first. That's because the pointy end has a smaller surface area, which means more pressure is applied to the wood. Section 8. Motion. It's all relative. Motion is everywhere. It's the change in an object's position over time. We describe motion using concepts like speed, velocity, and acceleration. Speed is how fast an object is moving. Velocity is speed in a specific direction. Acceleration is the rate of change of velocity. So, if an object is speeding up, slowing down, or changing direction, it's accelerating. Section 9. Conclusion. Physics is everywhere. From the force that keeps us grounded to the light that allows us to see, physics is behind so much of what we experience in our everyday lives. It's the science that explains the how and why of the world around us. So the next time you see something cool or experience something interesting, take a moment to think about the physics at play. You might be surprised by what you discover. Remember, science rules.